Hello friends, welcome to Brain Amplifier, and this is the third part of our series of video regarding harmonics. And in this part we'll try to learn about the odd harmonics, and particularly we'll try to think about the Triple-N harmonics, odd Triple-N harmonics. What are the Triple-N harmonics? The harmonics that are 3 and the integral multiple of 3, there are 6, 9, and 12. These harmonics are called the Triple-N harmonics. If we want to see it graphically, if this is my fundamental harmonics 0 to 180, this part is my fundamental harmonics, then this will be called my third harmonics. That is, in 0 to 180 I have 3 ups and downs of this waveform. This will be called my third harmonic. And you see one thing, if this is my 0 to 180, each part of this third harmonics is of 60 60 60. Okay, now this part is very important to understand. See, you can see 3 waveforms, each of R phase, Y phase and B phase. Okay, now one thing, you can see these waveforms R phase, Y phase and B phase. Now see these waveforms, R phase starts from 0, 180, this and this. My Y phase starts from 120 degree, because Y is 120 degree ahead of R, so it will start from 120, and like this. I am talking of fundamental waveforms. And my B is 240 degree ahead of my R and 120 degree ahead of Y, so it will start from here and this waveform. Now this I talked about fundamental. Now I draw third harmonics waveform of all these three. I draw third harmonics of R. Okay, I draw third harmonics of Y. You may start from here or from here. I may make third harmonic of Y. I draw on third harmonics of B also, like this. Now all these are of 60 degrees each. We have understood that. Okay, because this is 0 to 180, this is 60 60 60 60 60 60. These also are 60 60 60 60 60 60 60 60 60. Now one thing to understand is, my fundamental waveforms of R, Y and B are 120 degree ahead, 120 degree apart from each other. But if I see my third harmonics waveforms are in phase, you should see it carefully. My third harmonic waveforms are in phase, they are not 120 degree apart, so they are not going to cancel out each other. Okay, so these will behave like in a additive property. So in the final waveform, in the return, these will add up and result in a high current value. Okay, so if I understand, my fundamental is 120 degree phase apart, but my third harmonics of R, Y, B are in phase, that is, they will behave like additive. Okay, so these three will add up to each other. Now if I want to understand it mathematically, see, if my fundamental is V cos omega t, V cos omega t minus 120, V cos omega t plus 120 degree for A, B and C, then my third harmonic will be V and 3, V cos 3 omega t. I have multiplied this omega t by 3. V and 3 will be V cos 3 omega t minus 3 into 120, that is 360, and I will get V cos 3 omega t, that is similar to V and 3. VC and 3 will be V cos 3 omega t plus 360, that is V cos 3 omega t. So what I see here, that all these three values are same, that is VN3 equals to VBN3 equals to VCN3, that is, they are not going to cancel out each other, but they will add up in the return line. Okay, so what will be my net current in the return line, or net voltage? That is V3 of third harmonic, net voltage of third harmonic in the return line. The current behavior of current will be the same. V3 equals to VAN3 plus VBN3 plus VCN3, that is 3 times of any of these VAN3. But my fundamental voltage in the return line, or fundamental current you can say, in the return line will be VN plus VBN plus VCN, that is equals to 0, because all these three are 120 degree apart. So what will be the effect of this? my fundamental wave phase will be look like this. This is R, Y and B. These are 120 degree apart, so in the final line they will cancel out each other, but my third harmonics are in phase. So if I call it a positive sequence voltage or current, then this will be called zero sequence. Okay, so what will be the effect of the zero sequence? If I'm talking about any rotating machine, there will be no rotation caused by this zero sequence current or voltage, only it will cause heating in the return line. Okay, so I think I have understood my third harmonics will not be any useful for rotating any machine. It will only cause heat up, it will cause higher third harmonic current in the neutral line. That is, if I'm giving return from the neutral, it will cause high heat value due to my high I. So I is more, then I square R losses will be more. So I think you have understood the third harmonic concept. So what is the solution for this? Okay, if IN, my total return current in neutral will be INS plus IBNS plus ICNS, that is I cos 3 omega t, that is 3 times of normal current. Okay, so high third harmonic neutral current will be the resultant of this. What is the solution? The solution is delta connection. We'll try to understand delta connection in the next video. Thank you so much.